The first type of a first order differential equation we are going to talk about is the linear equation. We need to talk about this carefully because if we have examples that are actually linear equation, we can also have another method aside from separation of variables. We can have another method in solving such. Now, if we have a first order differential equation, in specifically in this form, you have here a sub 1, where a sub 1 is any arbitrary constant. You have your x variable. You have your first order here, the first order derivative of y with respect to x, plus your a sub 0 is also another constant. You have here your x and y be equal to, let's say, another function g of x. This is an example of a first order differential equation because you have here the degree is actually just equal to 1. Okay, and of course, we have here our variable y, which should be present together with x, or may not also be available for x there as long as it's written in this manner. And then the remaining side is purely any function with x. We can transform this into a linear equation in standard form if we're going to retain this on this side of the equation. Hence, we are going to divide all terms or multiply all terms. We can have here multiply all terms by a sub 1 times x. Okay? Sorry, 1 over, because we're going to divide all of them or multiply 1 over a sub 1x. So what will happen here is this now. Okay? So for our first term, we'll only have the first order derivative of dx over dy, or the first order derivative of y with respect to x. And then later on, you will have here plus a sub 0 of x of y over a sub 1 of x, and is equal to g of x over a sub 1 and then times a variable x. Okay? Or any function with x times any constant a sub 1. Now, if we're going to let this be equal to certain p of x, and then let this equal to f of x, we'll have this final form here of our linear equation. Okay, the first order derivative of y with respect to x plus p of x y is equal to f of x. This is a standard form of a linear equation. And we are doing this because to solve this, we are going to use specific processes such as integrating factor related to the use of this function here on your right hand side and this function p of x paired with our y variable. If we could transform that in this manner, then our given is a linear equation, and then again, we'll be using its specific process. We'll be providing another video for the solution of any linear equation, and discussion, of course, of one of its quantity or criteria in solution, which is also called as the integrating factor. We'll talk about that on the next few videos. Thank you very much for watching.